Thank you, Dr. Mirella. Thank you everyone for being here today, in person and online. Today I will present my work, which is a part of my PhD, which talk about a pedagogical prompt engineering protocol applied to large language model feedback in introductory programming. I'm pleased today that I show you my work and to give me this opportunity. Please feel free to ask any question. Here, Dr. Mirella will keep watching the chat. If anyone want to ask question or have a comment, don't hesitate. Please feel free. We can discuss during the presentation. First of all, will we start with the motivation behind this work? Then the problem that was identified in the literature, highlight the research gap that identified across the multiple studies that have been conducted by us. Then we will introduce the protocol, the Pedagogical Prompt Engineering Protocol, and explaining its structure step by step. Next, I will present the main outcome of the protocol, which is the initial application of the protocol using the LLM to generate feedback in introductory programming course. After that, I will show you evidence for both instructor and the student who engaged with this framework. And finally, then I will conclude with the critical practical implications and future work. So first of all, as you know, feedback play a critical role in learning, especially introductory programming course, because the novices need more than correction. Novices need scaffolding, guidance, which we should clarify what they're aiming to learn, to understand what is the next improvement for the novices and how they correct their error. So mainly understanding their error. With the large classes these days and the number of students and the continuous exercise and assessment, it's make a large workload for the educators themselves. And it's hard to maintain at a scale for educator to provide individual feedback for each student and follow the principal pedagogical educational goals to make the student ensure that they understand the feedback and support their learning. So using LLMs now is increasingly now LLMs, the student adopting LLMs more than before. They can use the LLMs as the recent studies of CS educations explain that they can explain programming, debugging codes, and fix errors that generated, and maybe also revise their code and receive quick and good feedback for their solutions. So this is not surprising. We're seeing a rapid adaptation of LLMs, and the students are integrating them very naturally in their learning. Recent research, as we see here, is have a high adaptations of these tools. And our exploratory studies emphasize this picture. So in my first exploratory study, which examined that the current feedback practices between both two countries in CS education, the students reported low satisfactions. Nearly half of them are not happy with the feedback they are receiving. Also, in my second exploratory study, which examined the adaptation of LLMs among CS education in Saudi Arabia and United Kingdom, I found that many students had already adopted LLMs in their learning and to revise their work. More than half of them reported that they are using LLMs to provide formative feedback like ChatGPT. So whether an instructor choose to guide this process or not, LLMs shaping the student learning, influence their learning. Now, this creates an important opportunity for us as instructors, not to replace our judgment or existing feedback practices, but to support the extended formative feedback if there is challenge to provide feedback for each student. So although LLMs now can produce clear and fluent feedback, Still, they don't inherently understand what the students are accepted to learn, and what is the challenge of novices learning, and how the formative feedback should be applied. So in other words, that the models is responding to patterns in data, not to pedagogy. So this means that the pedagogical depth of feedback depends almost on the instructional guidance that we provide these models, which essentially call the prompt. However, in most current practice prompts are treated as simple instructional or technical instructional, but in education's context, a prompt should be treated as instructional inputs because they shape the educational importance of feedback for beginner learners. This instructional perspective on prompt design is largely missing, which is absent on current literature or on teaching practices, and this gap is what motivates our work. So to understand what is missing from current prompt, we conduct 3 studies, each relieving different of current prompt. The first study that we conducted is the limited pedagogical grounded, the first gap that we found, it is the limited pedagogical grounded in LLM generated feedback. We do a systematic mapping review of 35 studies, relieved a clear gap in existing research. So our main finding that most study relieved that the LLM feedback, like a basic and have evaluated by basic metrics like accuracy, fluency, and the prompt that is used to generate LLM often lack of the pedagogical alignment. So the prompt itself is designed basically, and also educators are rarely to involve in designing the prompt itself and limited to evaluate this output. So there is main gap in the current research that explain that or highlight that there is a lack of pedagogical foundation in design and evaluation. Also here, the second gap, we found it especially on the CS studies, which is the pedagogical weaknesses in prompt and LLM-generated feedback. Based on the research, the researcher prompt, we analyzing the prompt which used in CS research, we found that there's many show the basic development intent, such identifying error or suggesting improvement. However, the model not guiding to generate key formative principles. For example, missing to guide the model for clarifying learning goal, the feed-forward guidance, adaptation to the student level, and using the supportive language to guide these models to generate the feedback. So as a result, none of these prompts achieved a high pedagogical alignment. So on the other hand, we regenerate the feedback using the state of art at that time when we conducted the study was GPT-4. So when we regenerated this output, it was clear that the output is fluent and clear, well structured. However, there's key formative elements were largely missing in the output. The feedback lacked some learning goal, like formative learning principle, which is not clarifying the learning goal, no feed forward for the next step, no promoting for the reflection or make student to reflect on their own work, and no supportive or constructive tone. So overall, the feedback here, or the generated feedback, is more corrective than developmental. The third gap is found on the real instructional design prompt. We collect prompt from real word instructor written prompt. We analyzing instructor's written prompt, and we observed a similar pattern of that found in the literature, but it's more stronger here. The prompt is more basic than the research in the CS1. Also, it's not guide the model to deeply formative principle. So here it's focus, the prompt developed by the teacher focus mainly on correction, not learning. And we regenerate these prompts based on the CS context and using GPT-5 with the advanced model at the state of the time. LLM showed, yes, clear improvement, more fluent, more structured, the feedback supportive, but still there is missing key formative functions of the formative feedback. There is still no clarification for the learning goal and no clear next step. There is a few of them, but it's depend on the teacher's prompt who's guide the model from the beginning. Also, there is more important that to understand that the prompt given by the teachers give direct solutions instead of hints, which is not good for teaching novices programming, because they need to scaffolding their learning to guide them to understand step by step without relieving their questions. And also there's no support to make the students reflect and think about their questions. So mainly, even with the advanced model, the feedback remained corrective rather than supportive novices learning student. So here, from all three studies, one thing became more very clear, which is LLMs are capable, but they don't apply educational principle unless we explicitly instruct them to do what we want from them. So what limited the feedback was not the model itself, but how we instruct the model through the prompt. In other words, the prompt is the source of pedagogical guidance that the model receives. And when there is no pedagogy in the prompt, can be pedagogy in the output, even with a high advanced model. So the key questions emerged was, what if we could design prompt that enable LLMs to generate feedback that truly support the student learning and align with the pedagogical principle? So this question directly motivates us for the development of the Pedagogical Prompt Engineering Protocol, which is a systematic theory-informed process for designing pedagogical prompt that enable LLMs to generate feedback aligned with educational goals. So in this word, I take a different view of prompt or take a different view of prompt engineering rather than treating it as a purely technical activity, such as tuning parameter, adjusting some words. It's a frame pedagogical prompt engineering as a form of instructional design. In this in this view, the prompt engineer acts as instructional designer, guided by the learning objective, shaping the pedagogical rule of the model, not just how it responds. So the protocol builds on established work in AI for educations. In practical, it's aligned with Locking's view, Rose Locking's view that say that AI should enhance human learning than automated it. It also aligned with the human in the loop approach in AI for education research by keeping educators actively involving in guiding and evaluating how LLMs are used to meet the educational goal. So what the protocol adds is design contribution. At a high level, it contributes a structured theory-informed approach from translating pedagogical intent into prompt design so that LLM's output are shaped by pedagogically rather than ad hoc instructions. So this is how protocol, as you see here, struct. It's based on 4 steps that translate pedagogical intent into a structural pedagogical framework. These steps describe the design process. It's followed by the pedagogical prompt engineer before the prompt is used in practice. So the mainly who's responsible to follow the protocol to generate finally the pedagogical framework is the pedagogical prompt engineer, which is the instructional designer. So the first step here, as you can see, it's about defining the educational process. So what the LLM output is meant to support pedagogically. So what is the main educational purpose that we need? This step is very critical because it sets the foundation for all subsequent design process. So the output of this step is a short design brief that clearly state the educational purpose, the target audience, and the pedagogical goal. So this brief guidance is make sure that our rest process will be based on this brief. The second step is about extract and integrate foundation evidence. So it's mainly focused on building a robust evidence-based to inform the prompt design from the literature. So here the prompt engineer will collect and integrate evidence across four complement layers. Each layer completes the other layer. So, and each layer addressing different aspects of design. Starting with the first one, which is the first layer, the targeted audience needs. Here in this layer, evidence is gathered about what the target audience needs, what they need to meet the goal of the framework that will build. So this ensures that the prompt guides the LLMs to produce output that align with their needs, rather than being generic or misaligned their needs. Here, moving to the second layer, which is the pedagogical foundation, evidence here is gathered about which educational theories and feedback principles should guide the LLM output. Here, it's very important to ensure that LLM's output serve as a clear instructional process. And the third layer, which is the best prompting practices, evidence here is gathered from the previous or recent LLM-based educational research and practices. So we should understand about what has been shown in this work in especially designing the prompt. So this helps that we ground the prompt design decisions in, based on empirical evidence have been conducted before in the previous research. Also, the last layer here, which is the technical prompt design principle, evidence here is gathered about how model constraint and provider guidelines affect the LLM behavior, help to ensure the pedagogical design prompt produce consistent output across different LLMs. So finally, when we integrate all these three layers, the output of this step is integrated multi-layered evidence repository. So the output here, repository of evidence from the literature based on three different layers. So this repository serves as foundation for all subsequent prompt design decisions. And the third step here of the protocol, the prompt pedagogical engineer translates the repository of the multi-layer evidence now into clear practical design principles. All the evidence that we collect before from the previous step, now it's translated to clear prompt principles to design the prompt itself. This step is important because it's ensure that prompt design is systematic and research informed rather than based on intuitions or trial and error. So the output is a set of actionable prompt design principles that directly guide the construction of pedagogically aligned prompt. The last step, which is a synthesized principle into core components. Here, the prompt engineer synthesized the design principle into higher level core components. So rather than treated the principle as like just one unique principle as isolated rules, they are integrated them through a thematic analysis. So this step is important because it's moved beyond organizing individual principles and instead produce a coherent set of components aligned with the educational purpose. So the output of this step is like a set of core components or core prompt design components that form a structured foundation for the prompt design. So finally, now the protocol produced a theory-informed pedagogical prompt engineering framework. It's not a single prompt, but it is a pedagogical framework to design prompt that grounded in educational theory. This framework provides a clear and replicable structure for prompt design. In practice, it serves as a design guide and educational references for integrating LLMs into educational practices. So to demonstrate how the protocol works in practice as a design methodology, I will start with the aim of integrating LLM into feedback practice. Then I will apply each step of the protocol to design a prompt for LLM-generated formative feedback. So here now, as we mentioned, our goal or our purpose, now we were following the protocol for our main purpose that generate feedback using LLM. The audience here, novices learner in introductory programming course, and the pedagogical goal for our generated feedback is to provide effective formative feedback that support student learning and understanding. So now moving to the next step, we will extract and integrate foundation evidence. So in this second step of the protocol, we collect the evidence across 4 layers. In the first layer here, I reviewed the novice's learning needs in CS education to ensure that LLM-generated feedback align with their needs. For example, here, from the review that we should explain what, how, why to fix the error to make the student or novice student to or to support their learning. Also use hint and step-by-step guidance. Avoid direct answer, especially for the novices students. Make the feedback a clear, direct language without any difficult word or advanced word for their learning. So after we building our evidence here, we move to the second layer. We review the educational theories and the feedback to ensure that LLM-generated feedback generate effective feedback and support the student learning. Here, for example, we focus on different theories. We have cognitive load theory that reduce cognitive load. Also scaffolding theory that focusing on how scaffolding the novices learning. Also based on the self-regulated learning theory that supports self-regulations for the student and clarify the goal and next step and what is the student should understand based on Hattie models. And also review what make the feedback is formative feedback based on short formative feedback principles. So after we build our evidence based on the pedagogical theory, now we move to review the best prompt practices that reported and CS LLM generated feedback. We review each research and we found what the researcher highlight or give recommendation to design the prompt. And this is very important to ensure that effective designing prompt based on the empirical study that have been conducted before. For example, here, we should customize feedback on the student achievement level. Also, the student or the structured feedback, which should be entered to scaffolding learning, like make it step by step. Also here, use a keyword like hint when you're designing the prompt because they approve that when using hint is not provide the direct solution for the student. Don't use like the word not give the solution. Also here, separate progress feedback from the next step guidance. It means like don't give the next step guidance with the feedback itself. Make it as in different section. After that, we review the LLMs providing prompting guidance to ensure the consistent output for LLM across different LLMs. For example, here, use precise language and avoids difficult words, specify the target audience and what's the desired tone and style. So all these evidence was collected together and to have like a multi-layer repository of evidence. Now, in the third step of the protocol, we translate the repository of a multi-layer review now into clear practical design principle. In our work, our repository contribute in 55 prompt design principle. To illustrate here, this is like the process as example showing how pedagogical foundations principle, which are found in the second layer, translated into a single prompt design for as a one example. Now, from the repository, we translate all the evidence to be as a prompt principle, and it's contributed in 55 prompt design principle. After that, the fourth step of the protocol, we synthesize the design principle into core component. Here, based on the thematic analysis, in short, I review the design principle, all of them, then code it as a theme, group them into themes, and refined and named the theme itself, and finally synthesize them into core components. So based on our goal to generate formative feedback that supports student learning and understanding, this is the 10 components that resulted from the framework, which itself is the framework which represented as a guidance or design guide and a pedagogical references on how a prompt should be developed to generate effective formative feedback using LLMs to support the novice student. So this is the QR code linked to our recent Forensics of Education's 25 paper, which have been presented in Forensics of Education conference. This framework as the main output of the our protocol. So here we have full prompt example available, view a QR code. We would like to explore it in details, so take time to scan and review this prompt, because next step we want to see the generated feedback based on this prompt. And to give you overview, this prompt is designed independently by CS instructor in about 20 minutes with minimal refinement, and is based on the teacher, he's want to reuse it again in the similar task, which is the exercise for or problem solving exercise in Java for coding writing, showing that here the protocol from principle now to practices. So if you can see the protocol, the main design of the prompt based on the framework itself, you can scan it. And because I will give you one moment to scan and review. Next, we will evaluate, or not evaluate, we will see the feedback that generated from this prompt based on the student. It's clear. It's work.
Yeah.
To be sure, it is prompt
Yeah, yeah.
with the components, right?
Mhm.
Okay. I will take 1 minute for drink. So here, I would love to get your informal reflection about the generated feedback. Scanning the first QR code, you will see an example of feedback which generated for a student solutions to a Java programming exercise using GPT-5 with the same pedagogical prompt designed by the instructor itself. After reviewing the feedback, please scan the slide link. In one word, describe the pedagogical value of this feedback, just to hear your perspectives. Now I will show you the slide link. How can I move this, Dr. Mirna? It can be moved. So now we are seeing your word, what is reflected, yes. Until now, the main word is supportive, which reflect what is you perceived. It's interesting to see that your words reflect the value of feedback framework as supportive, helpful, useful, pedagogical, grounded, clear, effective, specific, valuable, comprehensive, and well structured. Yeah. Thank you for your sharing your perspective. Now, I will move to the empirical evidence. Now we will see what the educators and students say about this framework from the real evidence or real classroom settings in these two experiments. So here, first of all, we have evidence from instructor evaluating the LLM generated feedback framework, which called PPE-LLM framework. The instructor here mainly focus on evaluate the effectiveness of the framework and if it's generate pedagogical value for the students or not. Here, this study involved 21 instructor who's a CS instructor, have experience more than 2 years of teaching introductory programming and providing feedback for the students. Sorry. Mainly here, the instructor go through three main process. First of all, the instructor go through developing the prompt. And this session, we introduce the prompt, the framework for the instructor. I give him example and instructor about the prompt itself. Then instructor individually build and develop the prompt. After that, the instructor applied this prompt based on LLMs. He chose the large language models that he familiar about it, and he chose from the CS content that we provided before the experiments. Then he applied it and review the output of these feedback. In the third sessions, he evaluate based on three main concepts. First of all, the educator evaluate the feedback generated. Is it effective or not? Second, the educator evaluate the components effectiveness itself. Is it clear, complete, necessary or not? And finally, he assessed the usability of this framework based on the usability measurement. For this seminar, we focus on the result of the evaluating the effectiveness of the framework. And here it's based on the scale that we develop. This scale evaluate the generated feedback effectiveness through 10 criteria, which build based on pedagogical theory, based on, for example, clarifying learning goal. What is the purpose? Is it constructive focus? The clarity and well structures, align the learner needs, and is it understanding the mistake, improvement suggestion, hint based, metacognitive supported, and feed forward orientation. Basically, this scale is built based on the theory and the student need, which already we have as evidence in our first stage of the protocol. So here's structure showed acceptable reliability of this scale with alpha Krumbach 70.76. Overall, instructor here rated the feedback very positively with a high composite score of 4.6 out of 5. Also, as you can see in the chart, all criteria received high rating, indicated that the feedback was perceived pedagogically aligned with effective for novices programmer. Also, for the qualitative data overall, most feedback was positive. So the instructor perceived the framework as a comprehensive, support the learning rules, enhance educator rules, pedagogical aligned, helpful, effective. As one comment of some instructors from, for example, here, Australia, the prompt is complete and good to be used with long and complex text also. He confirmed that. But also here, some instructors noted that design the prompts required like some initial efforts. And this is considered mainly arrays because it is like early stage, especially for one-off tasks. However, once the prompt is designed, it can be used across similar tasks with the minimal ongoing effort. Also here, there's some comments raised about the required period training. This is reflect the language or the language barrier rather than the limitations of the framework itself. Now here we shift to the student perspective. They are examining how students perceive the feedback in terms of supporting their learning and understanding. This is study called an exploratory studies approach. Here, after CISA students completed a graded Java exam, their instructor designed a PPE-LLM based feedback prompt, then applied this framework on GPT-5 to generate feedback for each student. So the generated feedback was delivered individual via Blackboard for each student. After that, the student have perception or survey perceptions to answer about or to evaluate the generated feedback. Now here, to examine the framework from the student perspective, also a perceived learning support scale was developed based on 10 criteria to evaluate is the LLM generated feedback that support the student learning and understanding. So the scale now demonstrates high internal consistency with the Cronbach Alpha 0.89. Overall, the students reported strong perceived learning support with a high composite score of 4.46 out of 5. As you can see here in the chart, all items were rated highly, indicated that students perceived the feedback as clear, supportive, helpful, and understanding mistake, guiding for improvement, supporting the future learning. So for the comments from the student, overall, most student feedback was positive. Students perceived that the framework feedback are clear, well-structured, well-organized, supportive of their learning, impressed, very helpful. So they highlight its effectiveness in identifying strengths and weaknesses, also guiding the improvement through practical next step and supporting their understanding. So here, as we can see now, how we can use the framework or the protocol in general and how. First of all, for the educational research, they will extend and drive a new framework using the protocol itself. Then the instructor design pedagogical aligned prompt based on the framework that developed based on the researcher. After that, the developer also can instruct new tools or system based on the pedagogical or educational goal of this prompt. Finally, the institution can deploy the framework to generate feedback to the student based on the institutional policies. So for the future work, we're focusing to extend our work to do different control experiments with computer science to compare between the framework itself and the baseline, which are the current teacher practices, to see does this framework generate feedback that lead to higher perceived learning support than feedback from the non-framework. Also, we want to move to higher level CS courses and to see how students in more advanced CS courses perceive the framework. And we can go to beyond computing departments with different departments. Also, we can extend our work to have instructor or non-CS instructor to evaluate the framework. I will be happy if you, even in person or online, to share or to share us our validation process here and the experience and to try the framework and evaluate the framework. A moment for if someone is scanning the code. So finally, this is my PhD work, which built on recent accepted paper, and we introduced our work in ICALI conference and Foreignties of Education Fortis, which focus on computing and engineering education. Thank you for attending and listening. And if you have any questions, please feel free to ask any question to discuss through this talk.